Okay, so for all you do now, I would like you to compare those two sets of data using a measure of average and also the range. I would suggest using the median, and then come back and we'll talk through what you should have done. Okay, so we should have a median for 2010 of 10 and a range of 7 for 2011, 12 and 9. And what we can conclude from this is that on average, the temperature in 2011 was higher. However, in 2010, the temperature was more consistent because it's got a lower range. And those are really the only two things you need to say. So for today's lesson, we're going to talk through the pros and cons of using each of these three averages. So the mean, median and the mode, and that would then be how you decide which one of them to use for a particular set of data based on avoiding any of the cons. So to begin with, let's have a look at this. We've got a list of 9 salaries from office workers and their boss. We want to think about what the problem of using the mean would be for this set of data. And hopefully it should be fairly obvious to you that if we include this 57,000, it's going to have a massive effect on the mean, even though every other number is 11,000. So the problem with the mean is that very extreme values, or what we might call outliers, can have a big effect on the answer. So that's one of our cons of finding the mean. It's affected by extreme values. However, pros is that you're using every single number to do the calculation, which is what we want really, because we want something that represents all of our data. So thinking about cons of the median, if we have a look at this set of data here for 7 siblings, what might be the problem with the median? Well, it's going to be the fact that we simply aren't using all of the numbers to calculate it. So we haven't included all of the data. Sometimes as well, you might have a case where you get an answer that doesn't really make sense. So we might have ended up with a median sibling of 7.5, but obviously you can't have half a sibling. Pros, however, though, is it's not affected by extreme values. So where we had that 57,000, the median wouldn't be affected by that, and that would be therefore probably the best average to use in that case. Finally then, the mode. If we have a look at this set of data here for 10 students in a science test, what do we think the problem might be with using the mode? Well, it's going to be the fact that there isn't one in this case, because there's the same amount of every number. So the problem with the mode is that sometimes there may well not be a mode. What about this one? The mode of the following data is going to be blue, because we've got 5 blues. What about the mean and the median? The issue is we simply can't calculate the mean and the median for that set of data that we had. So the mode is very useful if all of the data is worded data, or what we call qualitative data, rather than quantitative data. However, it's not always useful if all of the data is different. And it's also not affected by extreme values. However, that does mean that it might be the case that it doesn't really represent our data, because the mode might actually be the smallest number that we've got, and we want something that's generally going to be a measure of centre. So finally, thinking about this question, which of the averages would be best to use for this? We've discussed it's not going to be the mean, because that would be affected by the 57,000. And in terms of mode or median, it doesn't really make a difference because they're both going to give you the same answer of 11,000. So when you come to do the worksheet, I want you really thinking about those pros and cons of each of the different type of averages and whether extreme values are going to affect it, whether your answer would make sense if you use that, and use that to decide whether it's the best average to use.